Okay, great. Thank you very much for that introduction. Just going to get set up a little bit. So I thought I'd put this into a little bit of context. The speed of transitions and new things. So it was literally 6 years ago that we started our Masters of Management Analytics program. And I swear I spent 30% of my time explaining to HR departments and HR hiring managers and stuff like that what analytics was. And so here we are, jump forward 6 years, and now analytics is actually kind of off to the side now, and seems like AI seems to be the big comment. So in 6 years, things change so much. And now with emerging technologies and things like machine learning and artificial intelligence, who knows what's going to be like 6 years from now, which makes it very, very exciting. So what I'd like to do with this panel, I'm going to have each of our panel members sort of introduce themselves. And we are being kept on the clock, so we've got about 2 minutes for each person. So we'll start with Jenny.
Hi everyone, Jenny Huey here. I'm with a company called Element AI. So we are an artificial intelligence company that was founded roughly a year and a half ago. A little bit about ourselves and what we do. The founders and the first team that sort of took this idea, what they wanted to do was they wanted to take cutting edge research that was being done in a lab environment for artificial intelligence and take that and translate that into transformative solutions for the enterprise. And so it's very much in our ethos to take research and apply that into a business setting. Company, year and a half old. We went from a founding team of 8 all the way to about 300 today. We have offices headquartered in Montreal, Toronto, Korea, Singapore, and London. And again, our target market is enterprise, so Global 2000. And what we do is we provide customized AI solutions that feed into our AI as a service platform, in addition to a services component to really help businesses figure out what it is that they want to do with AI. A little bit about myself. I've got a mix of corporate and entrepreneurial experience. Really decided a few years ago that I wanted to retire from my corporate life and focus more so on startups and early stage technologies. Prior to Element AI, my 2 previous companies were around legal technology and healthcare and wound management with components using machine learning and deep learning as well. Pleasure to be here. Thank you.
Great. Thank you. Simon.
Hi, so I also want to first observe, I don't know why there's a giant chair between us all. I feel like we're being set up here to be like, you're taking one position, you're taking another position, but I don't think that's the case. Yeah, so I'm going to cozy up. So my name's Simon. I head growth for a company called BenchSci. I don't know if anybody knows about BenchSci. We were very lucky to get some coverage last week when we announced our Series A. We were the first company first startup outside of North America to raise money from Alphabet, from Gradient Ventures, Google's AI venture fund. So what do we do? I was going to give a little summary, but you gave such good information. I'll give you a little bit more detail. So BenchSci, what we do is we use artificial intelligence to accelerate biomedical discoveries, but in a very specific way. We help scientists reduce costs on their experiments so they can run more experiments, and then they can make discoveries to find treatments for diseases faster. And in a little bit more detail, we ingest the scientific literature. We have trained a machine learning model based on having PhDs label a bunch of data to interpret the scientific literature and then transform that in such a way that when a scientist is looking for the ingredients that they need to do in their experiments, we can tell them which are the best ones, supported by the most published data as well as other sources of data as well. So if anybody's interested, I can talk to you more afterwards about this. We are hiring, so you can let me know if you have any. On a personal side, I've been working in technology for about 18 years, a little bit of a back and forth between startups and consulting life. I think at this point I much prefer the startup world, which is why I'm back into it. And along the way, I also did a master's in the history and philosophy of science and technology, so that allowed me to actually look at science and technology as a phenomenon and what it might mean and parallels between biological and technological evolution. I'm very personally interested in the evolution of technology, what it means for business, what it means for society, and ultimately what it means for the future of life, which we probably won't get into in this because it's a very short panel. And yeah, so I'm very excited to be here, very enthusiastic about the topic, and it seems like a really great panel.
Perfect. Thank you. Alex.
Alex MOHELSKY. I'm a partner at EY based in Toronto. I lead data and analytics nationally at the firm. That includes machine learning and big data as well. I probably about the first half of my career, I started off in software R&D and working with startups, and found my way into management consulting in the second half of my career. But then always consulting within emerging technology, and been pretty much focused on the advanced analytics and machine learning space at enterprises for the last going on 8 years now.
Perfect, thank you. And Tom.
I think it's me. So my name is Tom Emmerich. I'm a partner at Super Ventures. We're an early stage augmented reality dedicated fund in Silicon Valley. I'm originally from Toronto, but I moved to San Francisco 2 years ago to start this fund with 3 other partners. Our focus is on mainly fundamental technologies within augmented reality, or AR, which is the blurring between the digital and the physical world, which has a lot of overlap with machine learning and IoT, of course, with sensors. We've actually invested in 13 companies so far, one of which actually is in Vancouver and is a spatial analytics company called Cognitive 3D. Beyond that, I've been working in augmented reality and wearables since 2009. I began working in augmented reality and publishing at Transcontinental Media, and then moved to Rogers, trying to save paper and TV and radio because they were all dying with emerging technologies. Before moving into more of a community building role, I founded the largest wearable tech community of its kind called We Are Wearables here in Toronto, which grew to over 120,000, and that recently got acquired by a global XR, meaning augmented reality and virtual reality community of 250,000 called AWE. And so that kind of leads me into the final kind of part that I do, which is organizing many conferences in Asia, Europe, and in Silicon Valley around augmented reality. So I think I'm here to talk a little bit on the application side of ML and IoT, and so I'm really looking forward to this conversation.
Great, thank you very much. So we have a great panel, very diverse panel, which is going to make it very interesting, I think, as we look at what are we calling emerging technologies. So maybe I can ask again each of the panel members, but I'll start with Tom this way. We'll kind of go back and forth that way. So what do you think are the actual key drivers in emerging tech? So I think maybe from a macro level as opposed to a micro level.
Well, I think it's different between the consumer and the enterprise. But perhaps I can more generally say I think there's 2 main drivers. One is hype and FOMO, fear of missing out. So especially when it relates to emerging technologies like virtual reality or augmented reality, they hit the news hard. The media really spends a lot of time talking about these technologies. There's a lot of interest and curiosity, and it only takes one of your competitors to start to cause you as an organization to be interested in whether or not you should be dipping your toes within the same bucket. And so sometimes we see enterprise in particular embrace potentially too early on emerging technologies because of that fear of missing out. And it may also stem from the fact that they feel like they missed out on previous waves and it really screwed them over, right? But the more important, and I think the more positive driver is around economics and numbers and ROI. And so this is when especially the technologies have become cheap enough for enterprises to be able to consider, and the use and the value is good enough that they're able to derive some sort of ROI to at least cover the cost or even more. And I think in the augmented reality and virtual reality world, we're already starting to see that in the enterprise. The cost of these devices are no longer $10,000, $50,000. They may be not very well priced for the consumer, but when it comes to the enterprise, the price that they're at is quite lucrative. But more importantly, the devices are stable enough. They have some growth, of course, but they're stable enough to provide the applications to deliver a reduction in errors and emissions or an increase in productivity that can more than justify the cost of rolling out that pilot program.
Yeah, for sure. I think, again, personal opinion, but there was a study by MIT just in the fall, September 2017, and they talked about 85% of big companies in the United States wanting to implement AI, but there's only about 6 or 7% that actually had a plan to do so. So I think it's that fear of missing out that everyone's sort of jumping on this bandwagon now. They know they want to do it, but they have absolutely no idea what that actually looks like. Alex, thoughts?
Yeah, well, I think there's some similar themes I would go through. So I think one large driver is intense competition. So I think that adds to the fear of missing out. If the market or segment is highly competitive, then there's just that much more incentive to embrace emerging technologies to gain a competitive edge. Cost reduction and revenue improvement are always big drivers. And to the point you just mentioned, I spent a lot of time trying to build out the business case and do the initiative design around where people will actually get the value of leveraging something like artificial intelligence and machine learning in the enterprise. And it's not always very evident. One of the things that is difficult is that in a consumer market, you look at the adoption and the emerging technologies, they tend to be much faster than the enterprise, mostly because price points and desires, fear of missing out, coolness, and so on. If you can commoditize the end product to a certain point where a consumer can buy it and that adoption happens, it happens much more organically. But in the enterprise, you really have to start quantifying things at a different level. And once you get to that, the barrier starts to get a little higher. The standard gets a little higher.
Okay, thank you. Simon.
Yeah, I think I'm going to take a slightly different approach to this. So I think one of the big drivers that most people don't pay attention to are feedback loops and data flywheels. If you look at the companies that have been most successful in getting ahead in their market of late, they all have some sort of flywheel or feedback loop at their core. So something as simple as Amazon, which their whole mission is like get the lowest prices possible, which is going to attract more customers, which gives you more leverage to get the lowest prices, and then you get one flywheel going. Or Google, provide the best search results, you get the most users, you capture the data on how they're using it, which allows you to provide better search results, which gets you more users, and the flywheel continues. Or in hardware, someone like NVIDIA, they create their machine learning hardware, they then use that generation of machine learning hardware to design, build, market the next generation, so there's a feedback loop. And really, if you look at any of the companies that are like massively improving in any of their markets, there's always some kind of feedback loop there. So, and again, from a competitive standpoint, why are Google and Amazon battling for the voice interface right now? Because whoever puts out the best voice interface is going to capture the most conversations, and whoever captures the most conversations is going to have the best data set for training the next generation of machine learning for voice interfaces. And so there's an intense battle. And I think there's two big implications that you should take away from this. The first one is, don't enter a market where somebody has a significant lead and a major flywheel or feedback loop going. It's very hard to catch them. So if you look at Amazon and Google right now, think about Apple, whose Siri, frankly, I've Apple everything, but Siri sucks. And because of that, Apple is way behind when it comes to developing the voice technology. Can they catch up with a Google and an Amazon who are in more homes and catching more conversational data? I don't know, it remains to be seen. So you probably don't want to enter a market where there's an incumbent who's got a really aggressively processing sort of flywheel or feedback loop. And the second one is, look inside your own businesses and see where you have open loops. Because a lot of times you'll find companies where they've got data, they produce a model, they put something in market, but they haven't thought about closing the loop to be able to capture data back in order to continuously improve the model. And last week, or when we went through recently our Series A raise, we're talking to a number of like 50 potential investors in machine learning. One of the things that they were all looking for was some sort of closed loop around what we're doing to get the data, build a machine learning model, put it in front of customers, but how are we going to build that loop, build a flywheel to gain momentum? So that's what I would say is like it's not the only driver, but a big driver, especially for companies that get a massive lead on competitors, is a flywheel or feedback loop.
Okay, thanks. Jenny.
Yeah, some of the things that are happening at a macro level, in particular in Canada, that are really helping to fuel the growth and development of AI and machine learning, particularly in Canada, is that we're fortunate enough to have several AI innovation hubs here in Canada. Edmonton being a great innovation hub with a solid academic base to get talent from. Toronto, of course, which is anchored by a lot of great universities in addition to the Vector Institute. And of course in Montreal, where we've got a really excellent academic base as well, anchored by the Vado Institute, for example, or the Montreal Institute for Learning Algorithms, which is where we're drawing a lot of our talent from. And let's be very clear, some of the things that we're working on still have roots in fundamental research, and we're still trying to draw out a lot of the research to help improve some of the models that we're deploying in deep learning in a commercial setting. We need that anchor and that tie into academia, and so it's really helped to put Canada on the global stage as far as artificial intelligence and machine learning goes. And so we've been really fortunate enough to have that as a base here. I think another big driver at the macro level is funding, and I think we've all talked about that. And I'm sure, when Simon was going out for his A round, he probably had investors tripping over themselves to get in. We raised $102 million last May for our Series A, which was, at that point in time, it was the largest Series A for any AI company, which was eclipsed, I think, a few months ago by SenseTime out in China, who raised $400 million and is now valued at $4.5 billion, which is kind of insane. But there's this wealth coming in from the private sector funding coming in addition to public sector funding coming in. The Canadian government, in addition to provincial governments, have allocated a big portion of the research and development budgets towards building out the next generation of AI and machine learning researchers. And if you take a look at that compared to what China has as a national imperative, by 2030, they want to eclipse the US as far as AI development and researchers go, and it's going to cost them over $100 billion. And so, how do we compete against something like that? Well, we've got a very strong base to go from, so it's the dynamics with the researching talent, development talent, in addition to the financing, and then in addition to those things that are happening in Canada, it's really sort of the data that drives a lot of what we're talking about as far as training these models go. And so there was some interesting statistics that we were taking a look at. So 90% of the world's data has been created over the past 2 years, which is incredible when you really think about it. So we've got the funding, we've got the research talent, we've got the data, and we've also got the hardware in which some of these models have been optimized to perform under. You've kind of got this perfect storm going right now for the latest advancements in machine learning and deep learning, and it's ripe for what the enterprise needs, which are not toy models or toy solutions.
But I think that hardware point is actually a good point as well, because one of the drivers is the past wave, right? Mm-hmm. And so the reason why we're all here is because of the advancements within computing and the adoption of mobile computing in particular within the enterprise, within the consumer space. So what's interesting about all of the wave that we're talking about, this convergence of AI, machine learning, and IoT, is that it's not really starting from scratch. It's not really like the dot-com bubble that was, really building a foundation. This is layers upon layers upon layers, and so that makes things go faster. But we have to remember that the reason why we're here is because of the technology that we're trying to either improve or replace.
Yeah, for sure. So actually that leads me into my next question, which is more on the micro level. Are there specific technologies that you see that maybe you can talk about that are really emerging as sort of game changers? I'll start with Jenny.
Yeah, one of the things that we're particularly interested in is this concept around representation learning. So, we all talk about, using these massive data sets to help train models, and the more data that we have, the more accurate the output of the model is going to be. But one of the research areas that we're very active in is how do we use as little data as possible. In other words, how do we extract features from a small data set as possible so that we can gain representations to help us to identify patterns in the data sets in order to drive these models. And so that's something that we're pretty excited about. And when you think about it from an enterprise's perspective, and some of the challenges that they have with being able to aggregate, consolidate, get all of their data into a single source of truth. It's a difficult thing to ask. We've got clients that will take months and months just to get a set of data that they need to train a model for POC purposes. And when you think about it, it's unrealistic. So we think that that's pretty exciting, some of the work that we're doing in order to optimize representation learning so that we can train our models based on smaller, more specific data sets and hopefully use that to train additional models.
Okay, thanks, Simon.
Yeah, I'm going to actually build on that to talk also about machine learning. And I think very related, I think there's two types of machine learning that I'm personally very excited about and that we're starting to work with as well. And so, and a show of hands, how many people are familiar with machine learning enough that I don't have to explain, like, so, okay, there's a lot of familiarity. So the two that I think are really important right now and are going to be even more important going forward are reinforcement learning and generative adversarial networks. So reinforcement learning is just learning through effectively learning through trial and error with a reward function or some sort of curriculum learning to get something to perform a task or an output that you want. And it's important because there are a lot of challenges that we're trying to tackle or that are that people are trying to tackle in robotics or other areas where you just don't have the data. The data does not exist. Like if you brought a robot into this room and had to try to navigate the room, you know, there may not be a data set of rooms with chairs in it that you could use to train a model, allow the robot to do that. But there's advances in reinforcement learning now that are either using a model or model-free that allow now for these new applications where you don't have a data set or it's really hard to get a data set, but you can just set some rules and a reward function and have it optimized towards that. So that's something that we're experimenting with now for cases where there's just not a lot of labeled data for us to work with. And then generative adversarial networks are fascinating to me because I keep hearing people say that AI is great at prediction, but it's terrible at creation. There's no such thing as a creative AI. AI can't be creative. And yet if you look at what's happening with generative adversarial networks now, they are being very creative. You've got sort of toy problems like NVIDIA sucked in a data set of celebrity faces and then used generative adversarial networks to create new celebrities that aren't real people, but look, you'd swear you'd seen them in some movie, and it just can keep generating all these faces. So that's just a toy problem, but in a world that I work in with artificial intelligence for drug discovery, there are now companies, there's one called In Silico Medicine, where they're using generative adversarial networks to generate novel drug designs. So you can train the generative adversarial network on a data set of existing drug molecules, and then you can have it come up with new ideas, quote, for new molecules, and then those can be put into testing. So this is, to me, both of those are really interesting. One will allow machine learning to be applied to areas where you don't have a lot of data, and the other one's going to allow you to use machine learning to do creative exercises in addition to prediction, both of which I think are going to be hugely transformational for any business that's going to apply them.
Great. Alex.
Well, I'll take a different bend on all that. So again, from more of an enterprise perspective, if you look at what you described before about trying to use smaller data sets to learn and so on, and yet there's always this conflict with, well, we want to acquire more data to be more competitive, right? So it's like, okay, which one's going to work and so on, and then you have all these almost proverbs of more data beats better algorithms, and then big data and so on and so on. But I think one of the reasons why people are getting so intrigued about working with smaller data sets and not having to relentlessly label the data is because it is just so hard to get the data out of the organization. If you look at in the Canadian market, I would argue that many large enterprises are just sitting around just trying to do more in the space because they're just sitting around waiting for the data. And actually it's creating a lot of human turnover because everybody's hiring all these high-end people into the companies to do stuff, and they're just waiting for the data. So then they go search for jobs and they say, do you have data ready? And then they go to the next one because they think they have the data, and then they don't, and then they keep going on and on and on. And so, as I see people going through this life cycle, I kind of scratch my head and think, what people are really struggling with is fundamentally dealing with the basics, and they're fundamentally struggling with what I call the new legacy of the enterprise. So most people will look at the enterprise and say the mainframe is the legacy, and I'd say no, that's actually not really your legacy. If you look statistically at most organizations, they're wasting most of their time, 70%, on the new legacy. And what is the new legacy? The new legacy is your data warehouse, right? It is your marketing technology stack that uses rule-based systems. It's your anti-money laundering systems that uses rule-based systems that people are so incredibly attached to. And so while you get all these advances in emergence, I think that the hype and buzz around machine learning and AI is helping people look at this again, because this problem was here 6 years ago, it was here 7 years ago. They're looking at it again to say, how do we turn this around? But fundamentally, where I think that the real emergence that's needed is how do you deal with the new legacy, right? You've got Java applications that are 20 years old. You've got all these things, and people, when they try to solve the data problem to feed into machine learning, they're using constructs and concepts that are 20 years old, and fundamentally that's what's causing the blockage on data availability. And it's interesting because, rather than trying to solve that simple data availability, the market sees the demand and says, okay, we're going to try to figure out how to work with less data, right? So I just think it's an interesting observation.
Okay, Tom.
So I'm not going to talk about any of that, but not that I don't think it's interesting, it's fascinating, but in my world, machine learning is computer vision and IoT is like the sensors. And so if you want to think about what's happening on a micro level in augmented reality, it is the race to create what's called the AR cloud, which is basically indexing the world around us. So what's really fascinating about wearable technology and computer vision is that we're giving our computers senses, and we're basically waking our computers up. And so that allows for our computers to do a lot of work on our behalf. No longer do we need to type in our status updates or actually have to physically take pictures. Our devices can just be on, and all the information can be collected automatically if we allow it to be, like privacy and security aside. But more importantly, it's not just about giving our computers eyes. That's only one step. We have to also give it brains, and that's where the machine learning comes in. And so the AR cloud essentially is leveraging right now mobile devices to be able to map the world using your camera, and then creating a mesh of the world in order for developers to be able to place holograms within it, or from an analytics perspective, to be able to understand, what's in the scene, how has that scene changed, what's the flow of people, what's this location versus another location, both indoors and outdoors. And so from an augmented reality perspective, as it relates to data, the big race is similar to the race, what happened in the .com days when Google indexed the web to allow it to be utilized. Right now, the opportunity is taking digital and moving it from the constraints of the computer out into the real world, and somehow making sense of the real world from a data perspective so that it can be leveraged both from an analytics perspective but also from a developer perspective to create the application layer that's going to prove to both the enterprise and to consumers that augmented reality should exist. And so some of the benefits of having an AR cloud, and if you watched Google I/O this past week, they actually announced a significant update to their augmented reality system. They have this system called VPS, which is their visual positioning system, and they integrated this with Google Maps so that when you turn your camera on with Google Maps, it can understand where you are, and they start to overlay arrows to show you where you are. But even more importantly, not importantly, but a little bit more fun, they have this new fox character that you can actually follow, and you can follow the fox through your phone, and he or she will move about to actually take you to where you want to go. Beyond that, they also are updating their AR line game to be able to allow for multiplayer AR by using what they call AR anchors within the world. And they're doing this because, again, they have a shared mesh that's being uploaded to the cloud, and they can understand using their positioning where the holographic image is placed. And so because of the ability to index the world, companies are going to be able to allow for multiplayer augmented reality. They're going to also allow for holograms to be able to be placed in the physical world and then be left there. So if I left a fox in this room and came back tomorrow, that same holographic fox will be here. And then also the AR experiences will be much more robust. No longer will we have the floating, Pikachu in Pokemon Go. It'll actually look like it's here on the ground. And even more importantly, if there is segmentation that's being involved with the scanning and the creation of the mesh, you'll see actual objects be occluded, which means that the Pikachu can actually hide behind a chair and peek out and actually feel like it's actually here in the space. That's beyond, again, as I mentioned, the benefits of all the analytics of being able to understand the space, something that technology has not been able to do before because it didn't have eyes and the brains to be able to do that. So that's kind of like what's happening from an analytics perspective in the AR world, which is really exciting.
Yeah, for sure. And that's actually, I see augmented reality as being one of the big efficiency drivers going forward, because even developing a relationship with a customer, for example, if you can use some kind of quick scan of who that person is. So let's say you walk into a car dealership and the car dealership then says, through facial recognition, they know who you are. They can do a quick scan of your social media to find out what kind of lifestyle you have. Do you have like 5 kids, or do you like hiking in the mountains? And they can help predetermine what kind of vehicle you want, for example. Same thing with banking. What kind of products do you need? That sort of thing. And that augmented reality, being able to help that salesperson or that front office client-facing person, and being able to help them, make that relationship that much stronger. So I see we're down to 10 minutes. I think we actually had some other questions, but I think I'd rather open it up to the audience if anybody has any questions. Yes?
Yeah. Simon, you had talked about feedback loops and flywheels and generative adversarial networks. It seems to me that one of the natural consequences of that kind of phenomenon in the space is the development of an AI that is smart enough to design an AI that's smarter than it. And of course, the natural consequence, or the inevitable consequence of that, is superintelligence. And what my question is, what is the time frame, if any, where the control problem becomes something that we really need to worry about?
Yeah, so how many times has the singularity or related topics come up at this conference today, I wonder. They've done surveys of people who are much smarter about machine learning and much more ingrained in it than I am. And none of them can agree on either A, whether superintelligence is even possible or not. Some very prominent people say, don't even believe that we'll ever get there. You can have a recurrently self-improving AI. And they don't agree on the timeline, even amongst those who do. And they don't agree on the outcome either, whether it's going to be good or bad, or maybe neither. The best estimate I've seen is 2047. I believe that's what all the experts came up with when Max Tegmark held his conference and tried to survey them. 2047. Do I believe that or not? I have no idea. Because if you cast your mind back, none of us predicted that we'd be in this room with any of the devices that we have, or Google Homes, or even smartphones, or I don't think we do very well at predicting the future, and there's a tremendous amount of randomness. So in terms of the control problem, it's nice to see now that it's getting recognition. It's nice to see now that people like Eliezer Yudkowsky and his colleagues are well-funded, that you have an open AI, that you have people like Max Tegmark and the Future of Life Institute working on this problem. So I think that I feel like we may be ahead of it, but the thing that I find maybe unsettling, or not unsettling, but disconcerting, is that every time people say something is impossible now with AI, it happens much faster than it used to. So, we had AlphaGo, and in the same year, you had AlphaZero. Like the same year that you had an AI beat humans, you had a recurrently self-improving AI, AlphaZero, beat the AI that beat the humans, and 100-0 in a very short time frame. And so I would say we should be working on that problem as aggressively as possible, because I don't think we have any idea how fast it's going to come, and nobody agrees on it. I don't know if that answers your question, but 2047.
But I think that's actually the best point, the last point that you made. I don't think the question is when. I think the question is what should we be doing now. And I love some of the points from the last panel about understanding that we're teaching a machine, and what we teach it is what it's going to improve upon. And I think, if anything, we have to really take responsibility now for what we will be creating later. And we've seen this in every wave, social media with Facebook. You know, the time to have a cultural anthropologist or a philosopher at the table when it relates to technology to really infuse ethics into what we're doing has been more important than ever, especially with AI and what it's capable of doing. And so I think the question is not like when is it going to become, you know, all encompassing and omnipotent. It's what is it going to look like, and when are we going to take responsibility in what we are shaping today? Because we're creating those seeds, those foundations. And so I think that your last point is so crucial.
Perfect. Here's a quick poll. How many people actually took a philosophy course in university or college? Oh, a few people. That's a lot more than I expected, actually. That's good. I did. It's important. Okay, another question from the audience. Oh, right back in there. You've got a microphone coming to you.
Yeah, so just now Mr. MOHELSKY commented on there's a legacy problem blocking the implementation of using machine learning and AI. So question for Jenny is like, what's your comment on this? So do you encounter this kind of problem in your daily basis? And like, what's the process of dealing with this legacy system when you are working with your clients?
Yeah, it's a very good question. I mean, if we probably did a poll today on our target consumers or customers, which are the Global 2000, and asked them if they had planned their architecture around sort of an AI-first mindset, we'd probably have 0 responding with a yes. And so, you know, it's going to be a lot more advantageous for companies like Amazon, who had the foresight to really think ahead and plan their architecture around artificial intelligence and machine learning really being something that was more achievable in the near term than, say, someone like a Walmart, who had all of these legacy systems that were cobbled together via mergers, acquisitions, and it's just sort of the nature of the beast in large enterprises that you become a siloed organization the larger the company grows, and we do deal with that every single day. You know, the approach that we like to take and that we like to emphasize is that this isn't something that you just sort of rip, gut, and replace. You know, it's something that doesn't happen overnight, but what we like to work with our clients on is really thinking about what do you want to achieve, right? So what do you want to achieve and what is your North Star? And working back from what your North Star is, it could be, you know, we want to improve our demand forecasting by 10%. Right? I'm just using a baseline use case out there. And so working backwards, what does that necessarily mean? What are the current data sources that you have access to be able to predict demand? What types of new sources of data would you want to take a look at to help you to improve your demand forecasting? And then from there, it's identifying all the different sources of data. It's identifying internally where the data exists. Is it sitting on someone's laptop? Is it sitting in a filing cabinet that needs to be scanned and digitized? Is it sitting in a data warehouse that exists in Australia, or does it exist in the US? But these are questions that we ask, and you know, the good thing about what we do with clients is, you know, it usually takes them a couple of POCs and a couple of projects to really get a better sense of, you know, what it is that they need to do internally to enable themselves to become AI ready as an entire organization. And that sort of sets the stage, and it's something that we when we think about what we want to build for enterprise, is really the brain for the enterprise. So it's this entire layer of intelligence that will just be built up over time, but requires these sort of point solutions that get kind of put in place and that get chained together. So it's definitely a work in progress. It's not something that happens overnight. And it's part of the interesting reason why we're working with enterprise, because we really see this as part of, you know, a 3+, 5+ year journey with them.
The other thing to add to that is that half the battle is getting the end users past their legacy preconceptions. So if you were to look at a demand forecasting problem, right?
The way most people would do that today is that they would take a bunch of data, stick it in a spreadsheet, they may do some visualization, they'll look at some kind of trend or numbers, and then they kind of, at some level, kind of go like that and say, this is what I think is going to be the forecast. I mean, a lot of people may not completely admit to it, but even with complicated models, they're kind of just guessing based off of the visuals that they get, right? So you fast forward and they say, well, you know, let's solve this problem. And the relentless approach is, you know, well, let's build a whole new data lake and whatever you want to call it, and let's get data self-service and drill down and, you know, click through and we can look at everything. And you say fundamentally this is counterproductive to the AI machine learning problem. The whole point is so that you don't have to do that, right? That is the whole point. And so fundamentally, as people are building these things, in the past and in the present, they're actually creating this massive data legacy. You'll get people who'll say, you know what, I don't want to solve the forecasting problem with the machine learning problem yet until I solve the self-service visualization problem. And you'll say, well, look, to do what you're asking, you know what, to do that self-service and click through so that you can verify as a human that everything is perfect, millions of dollars and years later, right? But you could dump it all into a structure, do the analytics and machine learning, give them a better answer on what they do today in probably 2 months if they didn't take that approach. So it's literally the legacy of how it was done before and the legacy mindset of really how do they transcend from basic analytics and visualization and manual process to trusting the algorithm on what it is. Because even if you give them the machine learning algorithm, they're going to say, I still don't trust it. Now give me the visualization, the click-through so I can verify what the machine just told me. You're like, okay, but wait a second. That's millions and years to get everything together to do that drill down. You're supposed to trust this thing, right? Well, I want to explain it. Okay, well now you start getting into the past discussion of governance, explainability, transparency of algorithms, and so on and so on, right? And so if you look at the numbers of adoption at the enterprise level, you know, that's one of the big obstacles. However, as an individual, if somebody said, here's a self-driving car, you know, for $500, maybe there's a small chance it'll kill you. How many of you would probably buy it and try it out if the laws let you do it? You'd probably raise your hand and do it, right? So there's a big, you know, there's a big gap in terms of what the consumers are ready to do en masse that aggregate to big dollars and the acceptance of what they do and what the enterprise does, right?
Perfect, thank you very much. So I think we're out of time.
One more question.
One more question?
Yeah.
Okay, there's two of you there, but sure, I don't think you've asked one yet.
Coming from B2B business, I think the data is really small, and then a lot of business actually, the reputation is really small, maybe only 1 or 2 repeats business. So I'm just wondering like how actually AI will benefit for B2B business, and then should the B2B business invest on AI right now? So what is
maybe I can, we do B2B sales to pharmaceutical companies. I guess my question would be, this is one of those cases where you're saying AI is a very general term. And I guess my question back to you would be is, what's your business problem? Like what is the driver for you of your business growth? And what is the problems that you're having, and where will you get the most leverage out of applying AI? Because there are so many ways you could use it to drive your sales. Your sales communication, you could use it to drive conversation. You could use it to gain personality insights into whoever you're communicating with. I mean, I could go down the list of opportunities, but the bigger question I think is, you know, what is the business problem? What is the problem in your business that would most benefit from what AI can do, which right now is primarily inference or prediction, and very soon will also be creative output. I guess it's such an open-ended question. So yeah, that would be my thing. What's the biggest business problem, and where does AI have the most potential today?
Okay, and I think that's actually a good way to stop the conversation. So thank you very much. We're good.